Okay, please take that first example, and instead of 6x squared, let's write it as instead of 3x squared, write it as 6x squared plus 4, or times 4 plus x to the third to the fourth power. Okay? So, you remember, first semester when we took derivatives, you used the chain rule. Remember how efficient that was? And just to kind of bring back a point of reference, if you had the problem, I'll be with you in a second. If you had the problem, say 3x to the fourth minus x raised to the 100th power, and you needed to find that derivative, we talked about, wouldn't that be a real pain in the butt to multiply that out 100 times? And so we found an easier way, didn't we? We said that the outside was u to the 100th. And what was the inside? Great. And so then you took the derivative of each, 100u to the 99th, and good. So your final derivative was 12x squared minus 1 times, cubed, sorry. Got it, sorry. All right, times 100 times then 3x to the fourth minus x to the 99th power. Like, I mean, that's kind of impressive the way the calculus works. We could have multiplied it out 100 times, but it turns out it's as simple as that, right? So today you're going to learn the chain rule backwards. So just as often as you use the chain rule for finding derivatives, today you're going to use the chain rule kind of idea for antiderivatives, and we call it substitution. So what I'm going to teach you today is a multiple day lesson. It is, just think of how often you use the chain rule. Is a lot, right? You're going to use this a lot, okay? And so I look at this piece, and I want to find the antiderivative. That's what this piece means, indefinite integral, okay? So we need to find this antiderivative. And that doesn't look like something we've seen, does it? Doesn't look like something we've seen. And so just like you identified the inside before, we're going to identify the inside now. We're going to say u is equal to something. Anybody want to guess what u is equal to? What the inside part is? Yeah, 4 plus x cubed. Now, this is where you're going to have to kind of trust. But when we take the derivative of u, we call it du. That's a derivative of u. Okay, we're going to put a du. So 1 du, okay, equals, what is the derivative of 4 plus x cubed? 3x squared, and because we took the derivative of an x, we're going to attach a dx, okay? Dx is simply a statement that we took a derivative. So this thing is the derivative of something. You know, it turns out that 3x squared was the derivative of this guy. Okay, that's all that it means. You took a derivative. That's all it means. Everybody okay? So now the word is substitution. We want to substitute something in. Okay, and if you look, we got a lot of good things we can substitute here for. Okay, do you see a dx up above? Yeah, this dx is right there. Do you see an x squared up here? Yeah, I see an x squared right there, right? And so I have a number of things I can plug in. Do you see a 4 plus x cubed up here? Yeah, so you see that down here. There's one thing we don't see up here that we need to come up with. What's the thing that's up here that we don't see down here? Let me see it. The fourth power thing, we're going to take care of that. But notice how there's a 6 here, a 6x squared, but here's there's a 3x squared. You see that? So all I'm going to do is I'm just going to make sure that we come up with a 6x squared. How could we do that? Times it by 2. 2 times du is equal to 6x squared dx. And now all the pieces are in play. I'm going to make my substitution. And the substitution means this. that instead of having x as a variable, we're going to have u as a variable. So watch what happens. I have a new integral. And the first thing I'm going to do is I'm going to get rid of the 6x squared dx. So instead of the 6x squared and the dx, what do I get to put in its place? 2 du. Okay, so I'll put the du there. And you can put the 2 on the right side of the integral. I like to put it on the left side. So I just take the antiderivative and multiply it by 2 in the end. That's how that works. Okay. And instead of 4 plus x cubed, what can I put in its place? Yep, I get rid of that, and I can put u in its place, and it's raised to the 4th power. So I didn't have to get rid of that 4, because I know the antiderivative of u to the 4th. What is the antiderivative of u to the 4th? u to the 5th over 5, right? Times 2, because of the times 2. And then we got a plus c on the end, don't we? Because it's an indefinite integral. Anybody know what I do to finish this problem off? I plug u back in. So u is 4 plus x cubed. So I have 2 times 4 plus x cubed to the 5th power over 5 plus a constant. That's the antiderivative. So remember before when we would do the integral of x cubed dx, you would take the antiderivative and you would say you got x to the 4th over 4 plus c. The dx disappeared when we took the antiderivative. So when you do the antiderivative, this and this go away. They're gone. Yep. Better? Okay, Easton.
But like the 6x squared dx
Yeah.
multiplied 6x squared and dx is the same thing.
No, 6x squared dx is the same thing as 2 du.
Well, how did you get normal du? So we had all the variables.
The derivative of u is du.
And then you said that u is just that.
Yep, I decided u is that. Let's try the next one, see if that one comes clear, okay? So this takes a little bit of time. You did a good job following the first example. Trust me, we're not going to leave you on your own. This is one of those things where I have to get the whole class to get it. Otherwise, the next test is going to go absolutely horrible. So we're going to take baby steps, okay? I look at this one right here. I don't want to multiply out 3 times. That would be a lot of work, wouldn't it? So I'm just going to start by identifying u. What is u? 4x squared minus 3. So that's what I'm going to substitute. Now, some people wonder, how do you always know what to substitute? You don't always know. It's a tricky game. But most of the time, you can just look at the thing on the inside. If there's something on the inside, that's usually what we choose. So now I take the derivative. The derivative of u is du. The derivative of 4x squared minus 3 is 8x dx. Good. So that's all I do in my first step. And as I glance up above, do I have a dx? Yep. Do I have a 4x squared minus 3? Yep. Do I have a 7x? No, I've got an 8x. Any idea? Minus 1 is a good thought, but that we have to use multipliers. How about this? How about we get rid of the 8 by dividing by 8? Or 1/8 du is equal to x dx. Are you okay with that? But I don't want just x dx, I want 7, so I should multiply both sides by 7. So 7/8 du is equal to 7x dx. If you would like to do that one step, you sure can. And that's what people generally do over time. It looks like I have a really good substitute now. So I'm going to write the integral, and I do like to teach people to cross things off. People forget things from time to time. I write down the 7/8 integral du. And if I write that down, what do I get to cross off up above? 7x and the dx. I get to cross off those two things. Excellent. Now what do I get to put down? u to the third. And if I put down u to the third, I get to cross off this, right? Everything up above must be able to be crossed off. Otherwise, the substitution is not complete. Now we have an easy antiderivative, don't we? Yeah, we do. And so you have 7 over 8 times what? u to the fourth over 4 plus a constant. So in order to determine this antiderivative, all we have left to do is to plug in our value for u. And our value for u is simply going to be 4x squared minus 3. So 7 times 4x squared minus 3 raised to the 4th power. Sorry about that. Over what? 32 plus a constant. That's pretty impressive that we can figure that out that quickly. That's not too bad. We're not ready to move on to the next example. We have to make sure you know what the heck you are doing. So you're going to go on your notes, and you're going to flip to the very last page. You have some blank space there, don't you? So you're going to look at that blank space, and you're going to try 2 of them on your own. Okay? Oh, da 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 da. Thank you, Ryan. Okay, for the first one, we have 8x times 16x squared plus 2 to the 10th power dx. You want to try to work through that one on your own. Okay. And I'll give you the second one here. Next one is 4x plus 1 times 2x squared minus, or plus x minus 9 to the 100th power dx. Take some time, practice. I'm going to come around and help you, but we want to make sure you feel good about these before we move on. Okay, let's see what you get. U is equal to 16x squared plus 2. Du is the derivative of that, which is? Good. Now, notice that you're taking the derivative, and then later on you take an antiderivative, right? So that's what's confusing people, is they're taking derivatives and antiderivatives at the same time. I don't have a 32. How could I get a 32? Multiply by a 4th. Great. I've got 1/4 integral, and I've got a du. I get to cross off my 8x and my dx. And then I could cross this off if I replace it with u to the 10th. And the antiderivative of u to the 10th is? So it'll be u to the 11th over 44 when we multiply by the 4 plus a constant, and simply plug u back in, which is at 16x squared plus 2. 16x squared plus 2 raised to the 11th power over 44 plus c. There you go. That will be the third part of your test, is being able to find antiderivatives using substitution. We are at level 1 in terms of finding these antiderivatives. They do become significantly more difficult. Okay? This is the antiderivative. So what this means is, if you were to take this and multiply it out 11 times and divide by 44 and then take its derivative, you would come up with exactly this. Or if you just did the chain rule, you could find it and you come up with that. Okay? Let's move on to the next one, and then we got a couple other ones to practice. Again, this is a multi-day lesson. You guys are going to be given a work day to work on this because it's a lot of work, the problems I've given you. What did you choose u to be here? Good. So du is, and I'm really happy when I see that the derivative is 4x plus 1 because that's exactly what I have, isn't it? So therefore, I get rid of that by just simply writing integral du. So du takes care of both those things. That's really nice. And so what I have in its place is I have u to the 100th power. What's the antiderivative of u to the 100th? Yeah, so I got 2x squared plus x minus 9 to the 101st power over 101 plus a constant. Not too bad, right? Not too bad at all. Okay, in that same space, write down this one. Write down integral of 4 cosine of 8x dx. And then the next one, we will do integral of x sine of x squared dx. So what happens if we have trig functions? It's really no different. You just have to be able to see it, play its course. Very good. I heard some people say it. U is equal to 8x. We're going to leave the cosine entirely alone, kind of like how we left like the 100th power alone. And you'll see why. You don't have to get rid of everything. And so what is du equal to? Just 8 dx. Do you have an 8 dx? So I need to have a 4. So what will I do? So 1/2 du is equal to 4 dx. Do I have the necessary pieces for my substitution? Yes. The 4 and the dx go away once I put in 1/2 integral du. Did I get rid of cosine? Don't have to. I still have cosine of u. Finding the antiderivative of cosine of u, that's easy. That's something we've done before, isn't it? What is the antiderivative of cosine? It's just sine. So notice you have 1/2 sine of u. What is u? 8x plus a constant. That's my antiderivative. That's not bad, right? You try the next one on your own. Go. You were correct. Good job. I would write it slightly differently. I'd put the negative out front, but that's fine. Yeah. The antiderivative of sine is negative cosine. All right, help me out. What is u? X squared. What is du? 2x dx. Do you have a 2x? So multiply by 1/2 du is equal to x dx. So 1/2 and du, those get rid of my x and my dx. I have sine of u in its place. What is the antiderivative of sine? Negative cosine. So negative 1/2 cosine of u, which is x squared, plus a constant. Before I send you on your way, I'm not giving you another problem. I just want you to understand that right now it seems very, very simple. I could just change one number in every one of those problems, and it would go from a 5-second problem to a week-long problem. And for those of you who seem very confident maybe about it, if you were to consider the integral of e to the 1 over x squared dx, if you find that solution, please let me know. Yes, it is. This is why Calculus 2 exists right here. So,
That specific one.
in many ways, that concept, yeah. Yep.